Lesson 7.4, using sine and cosine to calculate length. Much like with the tangent ratio, the sine and cosine ratios can be used to calculate the length of an unknown side of a right triangle. So if we know one angle and any side of the right triangle, we can use one of the three trig ratios to determine the length of a missing side. Sine and cosine are used in problems involving the hypotenuse. So in this lesson, we're going to be finding side lengths of right-angled triangles using the same method that we did with tangent back in lesson 7.2, but now we're including sine and cosine. So in this particular example, they want us to find the length of side BC. So if you look at the triangle, we have a 50-degree angle, and we have one side, 5.2, and it wants us to find the other one, BC. So the first thing we'll do, and it's the same thing we do in all of these problems, is we label our triangle. So directly across from the right angle, we have the hypotenuse. And then directly across from the angle we're given, the 50 degrees, we have our opposite. And we have our other side, which is next to the angle we're given, which is our adjacent. Our second step is to determine which side we were given. So we were given the hypotenuse, which is 5.2 centimeters. And then we have to determine which side we're looking for. So in this case, we're asked to find side BC, so we're looking for the adjacent. So the sides we're dealing with in this problem are the adjacent and the hypotenuse. We're not dealing with the opposite side at all. So which ratio has adjacent and hypotenuse in it? Cosine does. So we're going to use cosine equals adjacent over hypotenuse, and we fill in what we know. We know the angle is 50 degrees. We know the hypotenuse is 5.2. And because we're looking for the adjacent, we'll fill it in as x for now. So our first step to solve this is the same as if we were solving for a side using tangent. So we take the cos of 50 degrees, which is 0.6428, and that equals x over 5.2. And then to get x by itself, we multiply both sides by 5.2. So 5.2 times 0.6428 is 3.34, and that would be the side length of the adjacent side. So the math itself is the same as when we dealt with tangent, just it's a little bit different because we have to determine which ratio now that we want to use. So let's look at the second example. So I want you to try this one. Pause the video, give it a try, see how you do, and come back. Okay, so we have to label our triangle. So directly across from the right angle is the hypotenuse. Directly across from the angle we're given is the opposite. And the side next to the angle we're given is the adjacent. The side we are given right there is the opposite, which is 6.8. And we're looking for the length of side DE, which is the hypotenuse. So in this problem, we're looking at the opposite and hypotenuse, and we're not dealing with adjacent at all. So which ratio has opposite and hypotenuse in it? It's sine. So the angle we're dealing with is 55 degrees, so we have the sine of 55 equals, we know our opposite is 6.8, and we're looking for our hypotenuse, so we'll fill that in as x. So in our calculator, we do the sine of 55 degrees, which is 0.8191. And this time we have the variable in the denominator in the bottom. So this is when we do that switch. So we switch the 0.8191 and the x, and we get x equals 6.8 divided by 0.8191, which tells me x, which is the length of the hypotenuse, is 8.3. So let's have a look at one more example. It's a word. A wheelchair ramp must reach up to a vertical height of 2.3 meters. If the angle of inclination of the ramp is 35 degrees, how long is the ramp? So we have to sketch a diagram. So here's my diagram. It's not the best drawing. So we have a ramp. It's going up on an angle. So the vertical height which is that straight up and down height, is 2.3 meters. The angle of inclination, which is the angle the ramp makes with the ground, is 35 degrees. So the length of the ramp would be that angled line. So think of a wheelchair going up it where the wheelchair actually drives. That would be the length of the ramp. That's what we're looking for. So take a second, pause the video, and see if you can figure out the length of the ramp using the information in this diagram. Okay, so let's label our triangle. So we have our hypotenuse, which is the ramp itself. We have our opposite, which is that vertical height. And our adjacent is the horizontal or the ground. So we were given the opposite side, and we're looking for the hypotenuse. So which ratio has opposite and hypotenuse in it? Sine. So sine of 35, because 35 is our angle, equals 2.3 is our opposite over x, because we don't know what our hypotenuse is yet. We take the sine of 35 degrees and we get 0.5736. And then because our x is in the denominator in the bottom, we make that switch. So x equals 2.3 over 0.5736. Put that division problem in our calculator, and we get that x is 4. So the ramp would be 4 meters long. And that's it. So try the worksheet that goes along with this lesson. That worksheet includes sine, cosine, and tangent. So remember, tangent is opposite over adjacent. So if you're dealing with the opposite and adjacent sides, you'll have to use tangent.